In the vast expanse of the cosmos, where time and space merge into one, humanity has always sought to unravel the mysteries of the universe. Join us on an extraordinary journey as we delve into the realms of the unknown, guided by the groundbreaking discoveries of the James Webb Space Telescope. Prepare to witness a revelation that challenges the very fabric of our understanding, a primordial galaxy as ancient as the universe itself. In June 2022, the James Webb Space Telescope discovered plenty of faraway galaxies. When it first took its deep field image, suddenly galaxies started to pop out of the darkness of time and space, revealing themselves. For the first time, the universe began to seem way stranger than we ever thought it to be. Galaxies emerged from what we believe to be the universe's dark ages, raising doubts over the science of our cosmic model. And it wasn't just a couple of galaxies. The Webb telescope found hundreds of them, and one of these galaxies was found by an Austin astronomer, Stephen Finkelstein. He named it Maisie's Galaxy, an ode to his daughter because they spotted it on her birthday. Initially, the scientist and his team thought that the galaxy had formed almost immediately after the Big Bang. In cosmic time scales, yes, they estimated it to have been around only 290 million years after the Big Bang, but after analyzing the galaxy with more advanced equipment, they found out that it's about 100 million years older than that. That still doesn't take away its title from being the oldest galaxy to have been spotted, formed only 390 million years after the Big Bang. Maisie's Galaxy has been officially declared as the oldest galaxy ever observed, but the record holder of being the oldest galaxy ever observed might not enjoy the first place for too long. That's right, currently there are about 10 more galaxies that the Sears team is now evaluating, which could be even older than Maisie's Galaxy. One can only imagine what would happen if we found more younger galaxies than this one. The gap between the Big Bang and the formation of the first stars and star systems is narrowing down with every new discovery by the James Webb Space Telescope, and this is not the only thing that has been discovered in just a year since it was launched. Recently, NASA has discovered a type of star that was only hypothesized to have existed, but NASA's powerful NUI in the universe may have finally caught sight of it, and with this discovery, our perception of the cosmos changes forever. The James Webb Space Telescope has spotted 3 candidate dark stars powered by particles of annihilating dark matter. Yes, you heard that. Dark matter, which is believed to constitute most of the material universe, cannot be seen by conventional telescopes. The only way we can chart its presence is through gravitational effects, such as when a massive galaxy passes in front of a distant star and magnifies the light. Just as normal stars like our sun are powered by normal matter, dark stars may be fueled by particles of dark matter. This is very exciting news, and it could finally open up a portal to answers we seek about the universe. How well dark stars, if they do indeed exist, may be key to helping us understand how the universe first got light. That's right, for about 15 years, scientists have speculated that dark stars were among the first our universe ever produced when it was just 700 million years old. Webb's observations suggest that the 3 distant objects, which are all from early in the universe's history, meet the key characteristics of dark stars. 1. They are luminous, and 2. They are too cool for fusion to be happening. There are a set of undetermined parameters that control the formation and evolution of a dark star and ultimately its observable properties. Scientists reported, but they also stressed that they had used plausible values for the energy of particles of dark matter in building the models for these theoretical objects. The 3 candidate dark stars, namely Jade's GSZ13-0, Z12-0, and Z11-0, may be the target of future Webb observations to look for dips or excess light intensity in certain frequency bands that may match other predictions for the energy of dark stars. The James Webb Space Telescope has already thrown other strange puzzles at scientists, such as demonstrating the number of galaxies created in the universe's early history that appear to be too high to match standard models of the history of the cosmos. At this time, it might have shown us what the true age of our universe is. I am freaking out too. Okay, picture this. Our universe is not the spry 13.7 billion year old entity that we once believed it to be. Instead, it could be a grand 26.7 billion year old. Yes, let that sink in for a moment. This finding is according to a new study by Rajendra Gupta, an adjunct professor of physics at the University of Ottawa. Fundamentally changes our understanding of the universe and may solve the puzzle of the impossible early galaxy problem. For years, we've been estimating the age of the universe using 2 primary methods. First, calculating the time that has passed since the Big Bang and the colossal explosion, believed to have birthed our universe. And second, By studying the oldest stars based on the redshift of light coming from far-off galaxies, the redshift phenomenon happens when light from an object moving away from us stretches towards the red end of the light spectrum. By measuring this redshift, we've been able to calculate the age of the universe in 2021 using a model called the Land of CDM Concordance. Scientists estimated the universe to be about 13.797 billion years old, but there's a problem. Some stars, like the Methuselah, appear to be older than the universe itself, and that's not all. The James Webb Space Telescope has discovered early galaxies that seem to be far too advanced for their age. These galaxies were around just 300 million years after the Big Bang, but they had the mass immaturity typically seen in galaxies billions of years old. What's more, they're much smaller than we'd expect. Adding another piece to the puzzle, this is where Fritz Wicky's tired life theory comes into play. According to this theory, the redshift we see might not be due to galaxies moving away from us. Instead, it might be because light loses energy as it travels across the universe. For a long time this theory conflicted with what we saw in the universe, but according to Gupta, if we let this theory coexist with an expanding universe, we can reinterpret the redshift as a combination of both these phenomena. But Gupta didn't stop there. He also introduced a new idea based on physicist Paul Dirac's hypothesis about coupling constants. These are fundamental physical rules that control how particles interact. According to Dirac, these constants might have changed over time. If we let these constants evolve, then the time for early galaxies to form extends from a few hundred million years to several billion years. That could explain why the galaxies we see are so advanced for their age. Finally, Gupta challenges the traditional interpretation of the cosmological constant. This represents dark energy pushing the universe to expand faster. Instead, he proposes a new constant that accounts for the evolving coupling constants. This change could help us understand why the early galaxies were smaller than expected. It also offers a more accurate picture of the universe. In the words of Gupta, our newly devised model stretches the galaxy formation time by several billion years, making the universe 26.7 billion years old and not 13.7 as previously estimated. The universe might be much older than we thought, and that could shed light on some of its biggest mysteries. Case in example, the latest findings from the James Webb Space Telescope. It has enabled astronomers to see things that they cannot explain from the depths of the cosmos. The Webb telescope has extracted light coming from 44 galaxies that formed during the first 500 years of the universe. According to the standard model of cosmology, the universe is 13.8 billion years old for stars to form, and then galaxies only within the first 500 million years is nothing short of a cosmic marvel that we cannot fully fathom. But wait, the story doesn't end there. The recent data from Webb's observation also found that the deeper you look, the more galaxies you find. Yes, astronomers spent 50 hours peering into the deepest part of the cosmos and spotted some of the first galaxies ever formed immediately after the Big Bang. You can also understand their dilemma when they discovered that some of these 40 early galaxies formed only 200 million years after the Big Bang. Yes, galaxies, not stars. It is not rocket science to deduce from there that the stars that form those galaxies existed much earlier than that. Now coming to the more fascinating part, yes, the Superstar telescope just keeps giving. The data from this observation also revealed that these primordial galaxies emitted a phenomenal amount of energy into space, 10 times more than scientists predicted. To understand it clearly, let's first look at this deep field image captured by Webb's MARI instrument. This deep field view of the cosmos shows vivid spiral galaxies in the foreground and a plethora of much older galaxies in the distance. Pretty much all these objects are galaxies. When scientists zoomed in on 3 of the highly redshifted galaxies in the background, they discovered that these galaxies were releasing unexpected amounts of energy. The data also suggests that they would have formed in the first 200 to 500 million years after the Big Bang, when the universe's age was 1 to 5% of today's. The big question here, though, is, how did these galaxies emit such a phenomenal amount of energy into space? Scientists found only 2 possible scenarios. Black holes are massive stars even bigger than the red hypergiant stars that inhabit the universe today. How the universe has evolved over billions of years, beginning with the formation of the first stars and galaxies and eventually creating the essential organic materials for life. But here is the thing. Ironically, they could not find light at the end of the tunnel because no simulations predicted such extreme emissions of ultraviolet energy. So what might explain Rajendra Gupta's model? But scientists are studying his theory, and pretty soon we will understand the true mystery behind the origin story of the universe. If you found this exploration of the primordial galaxy as enthralling as we did, don't forget to like, share, and subscribe for more extraordinary revelations from the universe.